So let's get started. We have 4.2, writing an equation of a line in point slope form. So point slope form of a linear equation that can be written, we can write this when we're given 1 point and the slope. So in 4.1, we were given a point and a slope, but we had to learn how to use that or plug that into a slope-intercept form and write an equation. Well, the good thing about point slope form is we can just plug in those numbers and sometimes we can just leave it alone. So let's see what we're talking about. So we have y minus y1 is equal, and remember our y1 is this value in our ordered pair. Our ordered pairs are always x and y. Then we have our slope, which is our m value or our rate of change. And then we have x1, which is the first number in our ordered pair. So let's review all the forms that we have. We have slope-intercept form, which is in the form of y equals mx plus b. And this is useful when we're identifying the slope and the y-intercept of a function. So we use this form most often, especially when we're writing equations from a graph or if we're writing equations from a word problem, because a lot of times we're given the initial value and then we're given the slope or the rate of change in a word problem. Then we have standard form, and standard form is ax plus by equals to c. So this is useful when we're identifying the x and y intercepts. So back in module 3, we had to learn how to graph from our intercepts. And if we were given an equation in standard form like this, it was easy to plug in 0 for our x or 0 for our y, and then find our y-intercept just simply by dividing. Then today, what we're going to talk about is our point slope form. So that is y minus y1 equals m times x minus x1, where we have a point of x and y and a slope of m. So this is useful when a point on a line is given and the y-intercept is not easily determinable. So if we don't get a nice, clean, and easy y-intercept, then we can use our point slope form. It's also very helpful when we're given parallel and perpendicular lines, which we're going to get to soon. All right, so let's go through some examples. We need to write the equation of a line with a slope of 3 and a point at 4, 2. So here is my point slope formula, y minus blank. So we're going to plug in our values. And of course, yes, I had everything color coordinated. So y minus 2 equals 3, our slope, multiplied by x minus 4. So now that I have this in point slope form, I can leave that alone because I have written a 2-variable linear equation. Now, 1b says that I need to write this equation now in standard form. And remember, our standard form is ax plus by is equal to c. So the first thing we're going to do is we're going to take our point slope form and we're going to distribute. So we get y minus 2 is equal to 3x minus 12 because I multiplied 3 times x, and then I multiplied 3 times a negative 4, and I got negative 12. Now that I have this simplified, now I need to try to get it into standard form. So I'm going to add 2 to both sides so that I get all of my constants on the right. So I get y is equal to 3x minus 10. And now I still have this x value here, and I need to move this x value to the left side of the equal sign. So I'm going to do that by subtracting 3x from both sides. So now I have the equation negative 3x plus y is equal to negative 10. And now I've taken an equation that's in point slope form and transferred it to standard form. Okay, let's look at 2a. So in 2a, we have a slope of negative 4 and a point at 1, negative 5. Now we're going to plug this into our point slope form. So I have y minus a negative 5 is equal to negative 4, which is my slope, multiplied times x minus 1, my x value in my point. Now, if I don't want to leave it in there, or if the question requires that I write it in slope-intercept form, that's going to be pretty simple. I'm just going to simplify the equation that I was given. So y minus a negative 5 equals negative 4 times x minus 1. Well, this negative and a negative, I can rewrite that as a positive 5 is equal to negative 4x. And again, I have negative 4 multiplied by negative 1, so I have a positive 4. In my next step, I need to subtract 5 from both sides. And when I do that, I get y is equal to negative 4x minus 1. Now I've taken my point-slope form and transferred it to my slope-intercept form. Finally, in question 3, I have write the equation of a line with a slope of 3 and a point of negative 3, negative 4 in point-slope form. So with all this, I'm going to do just like what I did previously, plug in my values. So I have y minus a negative 4 equals 3 times x minus a negative 3. And now I want you to try this on your own by writing it in slope-intercept form. So go ahead and pause the video, try this question on your own, and then come back and check your answer. All right, so now that you're back, let's see if you have it right. So y minus a negative 4 simplified to y plus 4. When you distributed the 3 to the x, you got 3x, and 3 times a positive 3 gave you a positive 9. Now, if you made a mistake somewhere along these lines, make sure that you go back and edit your work or edit your notes so that you have it correct in your notes. Once I have simplified everything, I can subtract 4 from both sides, and I get y is equal to 3x plus 5.